had a good week. Hi, everybody. So, classic Wednesday, Sunday. We are here for revision. Starting at 7 o'clock, foundation from 7 to 8. So let's pop on here. Foundation is always 7 to 8 p.m. and higher is from 8 till 9 p.m. I've picked a random paper. Hopefully that'll be okay for everybody. It's a calculator one tonight, so grab your calculators, have them ready. Do I have a video on rearranging equations? I definitely do. I definitely do. So if you head to TikTok search bar and you just search Hannah Kettle Maths rearranging, it'll probably come up. Izzy, that is amazing news. Yes, a 7. Look at you go. That is incredible. Izzy, you should be so proud of yourself. Well done. I'm so pleased you're finding these helpful and it's helping you to revise. I'm sure that represents a lot of hard work on your part, so really, really well done. Hi, Taylor. I'll start at 7 o'clock, so always 7 to 8 for foundation and 8 till 9 for higher. So I did a non-calculator on Sunday, so I'm probably going to go with calculator tonight. This is November 2017, paper 3. We've not done a calculator one in a little while, so grab your calculators, make sure you've got them ready. Yes, so I've got predicted papers on my YouTube. There's foundation predicted papers and higher predicted papers for EdXL and for AQA now. They are the first class maths predicted papers, and they're the best ones in my opinion. He makes them so well. And there's walkthroughs of how to do them, and you can download the paper from the link in the bio. The paper we're going to do today is not the first class maths predicted paper. It is November 2017, paper 3. You're so welcome, everybody. I do love our Wednesday evenings. No worries, just come back at 8 o'clock if you're doing higher. Come back at 8 o'clock if you're doing higher, and I will see you then. It's all good. I'm so pleased to help you. Yeah, Izzy, it's tricky, isn't it? It might be that there are students in your class who would find a lot of the grade 8, grade 9 stuff really difficult. So, no, I'm going to do EdXL just because that's the that is the exam board that most people do. AQA and EdXL is very similar. It's purely just the like the layout and the way they ask the questions is slightly different, but the content is exactly the same. Yes, if you're doing functional skills level 2, I would say the foundation is going to be helpful. Functional skills level 1, maybe slightly less. I will do the exam, so I start at 7 o'clock. I just come on early just to answer any questions and spread the word and remind people that I'm here so people can print off the paper if they want to. So feel free to print off the paper. And I do foundation from 7 to 8, and then I'll do the same paper, but for higher from 8 till 9. Is it possible to go from a 7 to an 8? Absolutely. Guys, the sky's the limit. You've still got 4 weeks. In fact, I'm pretty sure it's the 19th of May, isn't it? The first maths exam. So it's a month today. Impossible to know what the grade boundaries will do. If the paper is easier, then the grade boundaries go up. And if the paper is harder, no, the other way. If the paper is easier, then the grade boundaries will go, no, I was right, go up. And if the paper is harder, the grade boundaries will go down. It really depends on the paper. And obviously, I haven't seen the paper. No one's seen the paper. So we won't know what to do until then. Yes, Henry, you can absolutely go from a 4 to a 5. So get back, and from a 2 to a 4. Guys, get back your mock exams. Find out what the questions were that you lost marks on and really focus on those topics and get practicing. The more hours you put in, the more you practice, the easier it will be, the better it will be. So there we go. Do the predicted papers that are on my YouTube. Download them from the, there's a link in the description for the paper. Have a go and then you can use the paper on that. I don't normally put the live on YouTube, but I am currently streaming live on YouTube. So I might do tonight. It depends. I've never streamed to YouTube as well as TikTok at the same time, but I am doing so tonight. So we're streaming live on both. So we'll see. Had your exam on Monday so much harder than my mock. I think the pressure of it being a real exam always makes it feel harder, but I'm sure you'll have done great. I wouldn't worry about that. I'm sure you'll have done great. Thank you so much for all the likes, guys. Hi, Harry. Nice to see you. So I'm live every Wednesday. That's for everybody. And then I have some lovely subscribers who also join me for a live on a Sunday as well. I might just go and grab my water before we begin, or else I'm going to be coughing and spluttering. So we've got 9 minutes till I begin. So if you want to do this along with me, then print the paper off. It is November 2017, paper 3. It is a calculator paper. Yeah, if you're in year 10, absolutely give it a go. Jumping 3 grades is going to be a real stretch, I have to be honest. But never say never. With hard work, anything is possible. Bless me. Yeah, so I do foundation from 7 till 8 p.m. and then higher from 8 till 9 p.m. It's an EdXL GCSE past paper. You can get them from Maths Genie. That's a really good website for downloading past papers. And it's EdXL November 2017, paper 3. Absolutely. Guys, if you're wanting to go up a grade or a grade and a half, that's so doable. You just need to put the hard work in. You'll be absolutely fine. I've got a TikTok on all of the circle theorems. If you search Hannah Kettle Maths circle theorems on TikTok, it'll come up. And I managed to get them all in 3 minutes. I was very proud of that TikTok, actually. So Hannah, if you search Hannah Kettle Maths circle theorems, it should come up. No worries. The PDF for the predicted paper is in the description on the video on YouTube. So if you go to my TikTok account and you click my link tree, then all the links to my YouTube are there, to the EdXL predicted paper, to the AQA predicted paper. So there's a predicted paper from both. Hi, George. What do you do to go from an 8 to a 9? That's a really tricky one, because actually the content for a grade 9 is going to be really quite tricky to predict. But I would just say really kind of focus on those last few questions, those really tricky ones on the exams. And look at the grade 9 content on Maths Genie as well. No, a 5 on foundation. If you get a 4 in higher, it's a grade 4. Doesn't matter whether you sat higher or foundation. It's not a 5 in foundation. It's a grade 4 no matter what. Nathan, it's just about practice, okay? The more maths you do at this point, the more confident you're going to get, okay? So if you were really looking to boost your grade, your teachers have taught you everything you need to know in maths. So I would download a few past papers, give them a go. If there's a question you can't do, find out what topic it is, focus on that. The maths papers, they stay very similar. So if you can do a few of them well, then that would be great. The best thing you can do is the predicted papers that First Class Maths has made. They're linked in the link tree on my account, and also they're on my YouTube. So if you go to my YouTube, you can see on the foundation, there's foundation pages, foundation predicted paper, and on the higher, there's higher predicted paper on those playlists. What's better, a grade 4 in higher or a grade 5 in foundation? It doesn't matter. On your certificate, it doesn't say you did the foundation paper or the higher paper. It just says what grade you got. So if you get a grade 4, it doesn't matter if you did foundation or higher. If you get a grade 5 on foundation or higher, that's still just going to be a better grade or a higher grade. Yeah, a 5 in foundation is completely equivalent to a 5 in higher. It's exactly the same. Yes, I recommend Maths Genie. Love that website for revision. Really good. Liv is loving the nostalgia. 6 to a 7, just practice. So my YouTube is Hannah Kettle Maths. Hannah Kettle Maths is my YouTube. The papers you can download from Maths Genie. Right, 5 minutes till I start. So foundation is 7 to 8. Higher is 8 to 9. If you're higher and you want to do higher at 8 o'clock and you want to come back then, maybe go do the predicted paper that's on YouTube and then come back at 8 o'clock and do this one with me as well. Then you'll have done 2 hours of revision and you can give yourself a massive pat on the back. Depends. I can't tell you grade boundaries. It depends if you're higher or foundation. But my favourite website for looking up grade boundaries is MathsBot. Maths and then bot, BOT. If you search MathSpot grade boundaries, you can then change it to your exam board or anything else and all of the other stuff like that. Yeah, tips for GCSE, practice. Okay, with maths, I don't think it's about flashcards. I really don't. With maths, I just think it's about doing the maths. You can use flashcards to help you, but the more you do, the easier you're going to find it. Practice maths by doing maths. That is my, that is how I feel. EdXL and OCR similar. I would say that EdXL is more similar to AQA. OCR is only done by about 5% of schools. So it's in the minority, but a lot of the content is the same. Okay, so you're still going to have to solve equations. You're still going to have to add fractions. It's likely that you're going to get some index laws on the non-calculator paper. How many hours you want to study and whether you can go up a grade, I can't answer that, guys. Only you can answer that. So if you're on a grade 4 and you want to get a grade 4, great. You might just need to do a little bit to tick over. But if you're a grade 4 and you want to get a grade 9, you're going to need to be working day and night. Can I make a video about the predicted grade boundaries? No, because until we've seen the paper, we're not going to have a clue. I've marked higher, I've marked foundation. This year I'm down to mark foundation, paper 3. That's normally what I get put on. It's potluck what you get. Thank you guys so much for the taps of the screen and for liking and for following. And for sharing. Yeah, so we're going to do this foundation paper at 7 o'clock. I keep saying I'm going to go and get myself some water, but then I'm still stood here answering your questions. It's always the way. Right, I'm going to run quickly, get some water. Tap the screen loads for me, guys, because then hopefully lots of people will see it before we start. It's always annoying. People always pop on halfway through and say, oh, I've missed the beginning. It's really annoying. Yeah, exactly. Grade boundaries are set after. Thank you so much for the roses, Nathan. Grade boundaries are set after the exams. So we'll never know until afterwards, okay? Predicted papers are on my YouTube. If you go to my YouTube and you click on my profile, then you've got predicted paper there for EdXL, predicted paper for AQA, and there's a foundation predicted paper as well. And the links to the paper are in the description underneath. You can then download the paper and then do it. Girl, go get your water. I know, I'm awful. Right, I'm going to go now. I'm running. Got to stay hydrated, guys. Got to stay hydrated. Sweet. Right. Should we start? Should we go? Is it 7 o'clock? I don't want to start early because I feel like people come on just for 7 o'clock. No, you do not need to write anything. You might want to write it just because you might find it helpful, but you don't need to write anything. It's up to you. Come on, let's start. I know. The predicted papers are completely free. The ones on my YouTube, they're completely free. The live is currently streaming on YouTube, but it's the first time I've done that, so I don't really know if it will stay there afterwards or not. The printer's taken ages. EdXL, so the content, guys, the maths is going to be the same, right? So the more maths you're doing, the better. Don't worry too much about your exam board. Can someone remember that we're doing November 2017 paper 3? Because I feel like in a minute someone's going to ask me, and it's helpful if you guys can answer for me because I'll be doing maths. Okay, fab. Let's go. So we're starting with foundation. Foundation is from 7 till 8 and higher is from 8 till 9. So question number 1. Let me know in the comments if you know the answers. So 3,758 correct to the nearest thousand. So when we're rounding to the nearest thousands, this is your thousands column. And then the 7 is the next column. So the 7 is in the hundreds column. And that's going to tell you to round up. So that's going to be 4,000. Good. Yes, 4,000, 4,000. Perfect. Everyone's saying 4,000 in the comments. Well done. Brilliant. Question number 2. You've got y, add 3y, take away 2y. Good. So remember that the y on its own is just 1y. So I've got 1y, add 3y, take away 2y. And the 1y add the 3y makes 4y. And then we're going to take away 2y. And that does indeed give us 2y. So well done if you said that. Cool. Question number 3. Write down all of the factors of 18. Write down all the factors of 18. So remember that factors come in pairs, okay? Factors always come in pairs. So you're going to make sure that you've got all of them by making sure that you've got the pair of each of them. So I like to do them like this: 1 and 18, 2 and 9, 3 and 6, 4 doesn't go in, 5 doesn't go in, and 6 we've already got there. So there we go, that's all of them. And then you can write them in order: 1, 2, 3, 6, 9, and 18. Well done if you said that. Lots of you saying that in the comments. Well done. 1 and 18, 2 and 9, 3 and 6. Exactly. Perfect. Well done, everybody. Brilliant. So this is foundation from 7 till 8. We're doing November, what did I say? I said I'd forget. November 2017, paper 3. Okay. The table gives information about the prices of cinema tickets. We've got an adult ticket, a child ticket, and a family ticket for up to 4 people. Mr. Edwards and his 3 children go to the cinema. It is cheaper for Mr. Edwards to buy 1 family ticket rather than 4 separate tickets, but how much cheaper? So remember, we've got a calculator for this, so we're okay to use our calculator. We've got that there. So we can use that, but anything you type in your calculator, you're going to want to also make sure that you have also written down. So Mr. Edwards and his 3 children go to the cinema. So he could pay £7.80 for his adult ticket and 3 lots of £5.80 for the 3 child tickets. So if he bought 4 separately, that is what he would be paying. Now, £5.80 multiplied by 3 in my calculator, that bit is £17.40. So then if we add the £7.80 to the £17.40, we can see that the cost of him going separately or buying 4 separate tickets is £25.20. Now it says it's cheaper for him to buy a family ticket, and they're right, because if he buys a family ticket, that covers 4 people. So it will cover his adult ticket and the 3 child tickets. So that's going to cover it, isn't it? So that is cheaper, and it doesn't say which one is cheaper. It says how much cheaper is it. So then we need to work out the difference between £24.30 and £25.20. So I'm going to do £25.20, take away £24.30, and that's going to give me the difference, and that is 0.9. So that is 90p, and you can write it like that, or you can write it as 90p. That would be absolutely fine, but don't do the pound sign and the penny sign. Good, well done, Em. Hi, Lucy. Good, well done, Stephen. Brilliant. Okay, the film starts at 6:45 and the film lasts 102 minutes. What time does the film finish? This is foundation from 7 till 8, higher from 8 till 9. We'll get to the harder questions, don't you worry. So with these, I like to jump like a little, I can't think of the word, like a timeline, I guess. So from 6:45, I would always jump to the next hour. And I would say that that is jumping 15 minutes. I can then jump another 60 minutes to get to the next hour. And then so far, that is 75 minutes. So if I do 102, take away the 75 that I've just done, that is another 27 minutes. So then I'm going to jump 27 minutes, and my answer would be 8:27 p.m. So I find it easier, rather than trying to add 102, I find it easier to jump 15 minutes to the hour and then jump an hour to the next one and then see how many more minutes you've got at the end. No worries if you have to go. I do this every Wednesday and every Sunday. Foundation is always 7 till 8. Higher is always 8 till 9. Okay, 8:27 p.m. This is November 2018, paper 3. I think. Okay, Tice. I don't know how I'm saying that name, but hopefully you guys can correct me. Tice has a large bottle of shampoo. There are 2 litres of shampoo in the large bottle. Tice also has some empty small bottles. Each small bottle can be completely filled with 150 mils of shampoo. How many small bottles can be completely filled with the shampoo from the large bottle? It's a calculator paper, yes. So 2 litres, we know that that is 2,000 millilitres. A litre is 1,000, so 2 litres is 2,000. This is Edexcel, November 2018, paper 3. 2017? Oh, I said I'd forget. Someone who knows, someone who wrote it down. Can you please? 2017, paper 3, Edexcel. Oh, went too far. Sorry, sneezing. Okay, so then the small bottles are 150 mils. So I want to know how many 150 mils fit into this. So I'm going to do 2,000 divided by 150. And we've got our calculator. Oh. So I'm going to type that in. 2,000. I don't know if everyone can see. 2,000 divided by 150. And it is 40 over 3, but press that SD button. And that is 13.3 recurring. So we've got 13.3 recurring. Now, even if that was 0.8 or 0.9, we would never round it up, right? Because you can't just round it up and say, oh yeah, it's closer to 14, because you can't fill up a 14th bottle. It's not going to fit, right? You're not going to be able to have that much. So it is 13 that can be completely filled. 13 bottles would be your answer to that one. So 3 marks available there. If you said 13, you got 3 marks. Well done. Okay, question number 6. The incomplete pictogram shows information about the number of cycles sold in a shop on Tuesday. I really want that to say bicycles rather than the number of cycles. Anyone else? That annoy anyone else? Just me. On Tuesday, on Wednesday, and on Thursday. A total of 20 bicycles. I'm just going to say bicycles because I can't say it. It's annoying. A total of 20 bicycles were sold on Tuesday, Wednesday, Thursday. So these add up to 20. That's what we've been told. We've been told that those add up to 20. It says that 8 cycles were sold on Friday and 15 were sold on Saturday. Use this information to complete the pictogram. So first we need to work out what one of those bike wheels is worth. How many bicycles is that equal to? So how many full bike wheels have we got? We've got 1, 2, 3, 4, and then those 2 halves would make a 5th one. So 5 bike wheels, so 5 wheels equals 20, which must mean that each of them is 4. So that is 4 cycles or 4 bicycles. Good. So Friday we sold 8. So we're going to need to do one of those circles and another one of those circles. And Saturday we sold 15. So if we do 1, that's 4, 8, 12. And then I need to do 3 more. What does that look like? I can't do another whole one because I don't want 4 more. I just want 3 more. What would that look like? Yeah, 7. So someone said 75%. You're absolutely right. Yeah, exactly. 3 quarters. 3 quarters. Well done, everybody. Good. So it's going to be like that. Pac-Man. Yeah, exactly. So this is foundation from 7 till 8 p.m. Higher is from 8 till 9 p.m. There we go. So we've completed our key. We've completed all of the days. And that would be it for 3 marks. Question number 7. BCD is a straight line. ABC is a triangle. Show that triangle ABC is isosceles. Right, first things first. Even if you don't know what you're doing, can you find some angles to fill in? Can you find some angles to fill in? This definitely counts as revision, yeah. Well, I would count it as revision. I do this every Wednesday and Sunday, and there's lots of people that join me or have been joining me every Wednesday since January, and they're saying that they've gone up lots of grades, so that's really nice to hear. Okay, yeah, let's start with this one. So angles on a straight line. Now, it's worth saying that this does not get included, okay? When we do angles on a straight line, it's just in the same place that they count, okay? So I'm going to do 180, take away 117. What's that, please? Good. I would say well done, that person, but I'm not saying your username because it's very rude. 63 degrees. Very good. Thank you. 63 degrees. Wonderful. And then we know that angles in a triangle also add up to 180. So I've got 63 degrees, I've got 54 degrees, and then I need that to make 180 all together. So 63 add 54, that makes what? Let's add them together. 63 add 54 is 117. And then we know that 180 take away 117 is 63. So therefore, we now know that this angle up here is also 63 degrees. Now, remember, we've got to take it away from 180 to get that one. I know people always say I sound like the lady from Maths Watch. I'm not her, but I feel like I need to meet her because apparently we're voice twins. It's like one of my most commented things. Oh, thank you. That's really kind. So then we've got an isosceles triangle, yeah? Those two sides are the same. Those two angles are the same. Now, the only thing we haven't done, we're not getting full marks at the minute because it told us we have to give a reason and it's 4 marks. So what reasons have we used? Give a reason for each stage you're working. I might just say it rather than writing it because it's very boring just watching me write. So for this one, oh, thank you, Ryan. For this one, we use the fact that angles on a straight line add up to 180. For this one, we use the fact that angles in a triangle add up to 180. So those are the 2 reasons that we need to write. Angles on a straight line add up to 180, and angles in a triangle add up to 180. Happy with that? So write those down. I'm not going to write it down because it's boring watching me write things. Oh, no. I knew this was going to happen. The picture shows a bus next to a building. Oh, no, it's all good. The picture shows a bus next to a building. The bus has a length of 12 metres. The bus and the building are drawn to the same scale. Work out an estimate in height, for the height in metres of the building. Right. I'm very sorry to the people that are on this bus. Hold on, people. What do we think? How many of those buses are going to fit going up? 2.5? 3 maybe? There would be a range of answers allowed for this one. Do we think 3? This is 2017. It's on Maths Genie. I'll just make that. Do you think I drew that one a bit big? 2.5? Let's do it with both. Let's do it with both, and then we can be really sure that we're kind of covering all bases. There would be a range of answers allowed on the mark scheme, okay? So if you said 2.5, you'd need to do 2.5 times 12. So that's 1 lot of 12 is 12, 2 lots of 12 is 24, and half a lot of 12 is 6. So that's going to be 30. And if you said 3 lots of 12, that would be 36. So I'm saying any answer in between those, you'd probably be the same. Yeah, Jack, of course. But we don't need to be that accurate. And I haven't got a ruler. I haven't got a ruler on my iPad. It's only an estimate. No worries. Right. Question number 9. Nida writes down 2 different prime numbers. She adds together her 2 numbers and her answer is a square number less than 30. Find 2 prime numbers that Nida could have written down. Right. Give me the first prime number. What is the first prime number? It is ZXL, yes. What is the first prime number? Does anyone know? What is the first prime number? Yes, Scarlett. Yes. Louise, yes. Baron, yes. I know people always think it's 1, but it is going to be 2, okay? 1 is not a prime number because 1 only has one factor, which is 1. For a prime number, you need 2 factors, 1 in itself. So good. Well done, maths. 2, 3, 5, 7. 9 is not a prime number because it's in the 3 times table. 11, 13, 17, 19, 23, and 29. I would say it'd be a good idea to know them up to 30 if you're doing foundation, because they love questions about 23 and 29. Oh my goodness. If your maths teacher told you today that 1 is a prime number, go back to school tomorrow and tell them they're wrong. 1 is not a prime number. Okay, and we need to add 2 of these together and get a square number. So your square numbers are 1 times 1, which is 1, 2 times 2, which is 4, 3 times 3, which is 9, 4 times 4, which is 16, 5 times 5, which is 25, and 6 times 6, but that's going to be too big. So I need 2 of these prime numbers that are going to add together to make 1 of these. And there's going to be lots of different numbers here. I would say it'd be good to know a few prime numbers for higher, for the prime factorization, but on higher, you're likely to just be doing the prime factorization, the tree thing, where you circle the prime numbers. The highest I've ever seen on that is 31. So probably for higher, it's probably just a good idea to know them as well. Good. So some of you saying 23 and 2, because that would make 25. And some of you are saying 11 and 5, because that would make 16. And you'd both be correct. You'd both be correct. Oh, someone else says 7 and 2. Yeah, like that. 7 and 2 to make 9. Any of those would be correct. Any of those would be correct. I got an A* in my GCSE, but it was a long time ago. I've been a maths teacher for 11 years now. And I have a maths degree, which is fun. Highly recommend. So what shall I put? I feel like most of you were saying 23 and 2. I like that one. I'm going to put that one. But if you'd put 2 and 7, that would be fine as well. And if you put 5 and 11, that would be fine as well. The square numbers are the answer to 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. No worries. Okay, question number 10. Jim thinks of a number. 2/5 of Jim's number is 48. Work out 5/6 of Jim's number. Right, I am massively... Oh, thank you so much for subscribing. See you on Sunday. So if you're subscribed, you can join me on Sunday for these as well. But Wednesday is always free and open to everybody. So 2/3 of Jim's number is 48. So I'm saying that is 48. Sorry, did I say 2/5? Thank you, Sophie. Sorry. They are 2/3 of Jim's number is 48. So that much is 48. How can I then get the whole number? If 2/3 is 48, then 1/3 is 24. Each of those sections is worth 24. Therefore, Jim's number is 24 times 3, which is 72. We've then got to work out. Now, I would say that fractions of numbers is probably the most common topic on foundation. I seem to do them about 3 times every time we're live. If you subscribe, I do it same time on Sunday, 7 to 8, 8 to 9. So when we do a fraction of a number, we divide by the bottom and then we times by the top. So 72 divided by 6. I got 24 because I halved 48. Thank you, Mads, for subscribing. Good. Loads of you saying 60. Really, really good. Well done, Sophie. Well done, Leah. Brilliant. So we divide by the bottom. 72 divided by 6 is 12. And then 12 times 5 is 60. Yeah, I do higher from 8 o'clock. So 48 was 2/3. So if I just wanted 1/3, it would be half of that. So that would be 24. So that means 24, 24, 24 to get the whole number. And 24 times 3 is 72. So Jim's number, all of this, is 72. We then needed to find 5/6 of 72. So you divide by the bottom and times by the top. 24 was half of 48. So 24 and 24, because I knew that that was 2 sections and I wanted to know what 1 section was. So then I times that by 3 to get the whole number. That bar represented the whole number. Okay, question number 11. Jack's driving school has 2 offers. Offer number 1, the first driving lesson is free and all the other driving lessons are a normal price. Offer number 2, all driving lessons, 5% off the normal price. The normal price of a lesson is £24. Douglas is going to have 12 driving lessons, which is cheaper, offer 1 or offer 2. And if you're doing higher, I start higher at 8 o'clock. So come back at 8 o'clock if you're looking for higher revision. But if you're sort of aiming for a grade 4, grade 5, it's not going to help. It's not going to hurt to watch this one as well. Okay, so let's do offer number 1 over here. And let's do offer number 2 over here. Now for offer number 1, the first driving lesson is free. So 1 is free. And then we would need to pay for 11 more. So 11 lots of 24. Now there's a trick to timesing by 11. You can put the 2 there, the 4 there, add them together and get 6. And it is 264. So it's going to cost Douglas £264 using offer number 1. Offer number 2, we get 5% off. So 10% of 24 is £2.40. To get 10%, we divide by 10. If you then want 5%, it's just going to be half of that. If you know that 10% is £2.40, then 5% is going to be £1.20. So that's how much we get off. So that means each lesson is going to be £22.80. And we need to pay for all 12 of them. So just typing that in my calculator, we have got a calculator for this test, is £273.60. Do we still think offer 2 is cheaper? I'm not sure, guys. Lots of you saying offer 2 is cheaper, but I'm pretty sure it's going to be offer 1. Yeah, so £264 using offer 1 and £273.60. Yeah, offer 1 is definitely cheaper. Now, remember, whenever they ask you a question, which is the cheaper offer, offer 1 or offer 2, we need to answer that question or we're not going to get full marks. So once you've laid out your working, you then need to answer the question, which is cheaper, offer 1 or offer 2. So we're going to write offer 1 is cheaper. You wouldn't believe how many people lose that mark by not writing a conclusion. We took it away because the offer said we get 5% off. So we found 5% and we took it off. To subscribe, there should be on TikTok, there should be a button up here. If you're following me, you should then be able to subscribe. If it's not there, it might be because I think you have to be 18. So you might have to get your parents to subscribe for you. Right, the 11 was because he wants 12 driving lessons. And on this deal, you got 1 for free. So that means you get 1 for free. So you only have to pay for 11. I got 10% because it's easy to get 10%. And then you can easily get 5% from 10%. So we didn't use that. We didn't use the 10%. We got 10%, and then we used that value to get 5% because it was half as big. Lily, you're absolutely right. So Lily said, can't we do 24 times 12 and then find 5% and take it off? And you're absolutely correct. That would work absolutely fine as well. You should get the same. So if I do 24 times 12, I get 288. And 5% of 288. Oh, hang on a minute. No, I'm good. 5% is still going to be the same, and you're still going to get £273.60. So 10% would be £28.80, and so 5% is £14.40, and that's what you're taking off. If you take off £14.40, you get the same. Okay, question number 12. Hello to everyone on YouTube, by the way. This is the first time I've streamed it live on both. It's quite cool having you all on different platforms. Okay, question number 12. 2.5 kilograms of apples costs £3.60. Work out the cost of 3.5 kilograms of apples. Cool, so 2.5 kilograms equals £3.60. Now, there are so many different things you can do here. I think I would just get 1 kilogram. How would I get 1 kilogram? What would I need to divide by? What do I need to divide by to get 1 kilogram? How do I go from 2.5 to 1? Good. Lots of you saying I need to divide by 2.5. So if I've divided the amount of apples by 2.5, I also need to divide the cost by 2.5. Sierra, you're very welcome. £3.60 divided by 2.5 is £1.44. Now you've got two choices. You could just add it together. Yep, Chanel, that will absolutely work. So there's a couple of ways we can do things now. We could say, well, actually, if I add these together, I will now get my 3.5. So the easiest thing I think to do would just be to add those together. Or you can take this value and times it by 3.5. That would also work. But whatever you do, whichever way you do it, you're going to get £5 and 4 pence. So you can either add those together and get £5 and 4 pence, or you can do £1.44 times by 3.5. That would work as well. Thank you so much, guys, for sharing with your friends. It means a lot. I do this every Wednesday and Sunday. I've given up 2 evenings a week since January. It's been crazy, but I mean, it's so nice to have you all along with me, and I hope you guys enjoy it as much as I do. Thank you so much. Also, I've uploaded predicted papers to YouTube, so if you want to go and give those a watch, please do. They're first class maths paper. They are the best likelihood to the real thing. They're so good, and they're on my YouTube if you want them. Foundation is 7 till 8, and higher is 8 till 9. Have a drink, guys. Stay hydrated. My voice is going to go. Okay, let's go. Question 13. Complete the table of values for y equals a half x minus 1. Oh, I love that. Thank you for your support anyway. No, TikTok doesn't pay me for this. Some people subscribe, and that's £5 a month, and that is on Sunday, but no, this one is entirely, I don't get paid anything, and roses are about a penny, but I don't do it for money. I do it because I know it helps a lot of you. I know there is a teaching crisis at the minute, and a lot of you don't necessarily have maths teachers, so I am here just to help, and yeah, I like that, and I know you guys appreciate it, so there we go. Thank you, Leah, that's really kind. Right, question number 13. So any coordinate on this graph the x coordinate and the y coordinate have to make this true. Thank you, Wendy. So half of x, take away 1, needs to equal y. So all I'm going to do to fill in the y's is I'm going to take x, I'm going to multiply it by a half, and then take away 1. So I'm going to multiply this by a half and take away 1. Now I've got a little hack for this, and that is that you're going to get your calculator, hit the fraction button and fill in a half, and then times it by the number, and I'm going to use brackets for that, and then take away 1. And all we are going to do is go back to that bracket each time and fill in the gap. So the first number that we're trying to do is -1. So I'm going to put -1 in that bracket. I'm going to hit equals, and it tells me that that is -1.5. So that's going to be my first one, -1.5. I'm then going to use my left-hand arrow, and I'm going to go back. Try to make sure everyone can see this. I'm going to go back to that bracket number, and I'm going to change it to 0. And that is -1. Yeah, I know you can use the table function, but not everyone knows how, and I feel like this is easier. I think this is easier anyway. Then change it to a 1, and that's -0.5. And then change it to a 3, and that is going to be 0.5. Does anyone know the gradient of this line? Does anyone know the gradient of this line? Can anyone tell me the gradient of this line? What is the gradient? The predicted papers are made off what came up lots on previous years. So the gradient is the number in front of the x when y is the subject of the formula. So you've got two numbers here to worry about. The gradient, the steepness of the line, is the number in front of the x. The other number here on its own is called the y-intercept. And that's where it crosses the y-axis. Good, well done, Tia. So if you wanted to know the gradient, that's how much it's going up by each time. So every time you go across by 1, this is going up by a half. So the gradient is a half. This is the equation of a straight line. Right, let's plot these points then. So -2, -2, that's my first coordinate, and that is here. -1, -1.5 is here. 0, -1 is here. 1, -0.5 is here. 2, 0 is here. And 3, 0.5 is here. You are then going to join that all up with a nice straight line going through all of those coordinates. And that is the line y equals a half x minus 1. Yeah, it could be on a non-calculator paper. Someone said, can I just show number 12 quickly? There you go. Yeah, so if you want to pop it in your calculator and the equation is y equals a half x minus 1, I just tend to put in a half times the value, take away 1. So where the x is, you're just going to put brackets in your calculator, and then you can just use the left arrow, go back, delete that number and change it to the next number. Oh, and then hit equals and it'll give you the next one. Does that make sense? Hi, Tom. Okay, next one. Question number 14. Describe fully the single transformation. Right, there are 4 transformations. Do we know them all? There are 4 transformations. If this says describe fully the single transformation, you are only allowed to pick one. You are only allowed to pick one. If you were to write more than one, you're going to lose all your marks. Okay, so we need to be really clear on the 4 transformations. We've got rotation, we've got reflection, we've got enlargement, and we've got translation. And they are all transformations. So if they ask you for a single transformation, you are only going to pick one of those words. You are only going to pick one of those words. No, if you're doing the IGCSE, you don't have a non-calculator paper. You've got a calculator for all of them. Who said we missed a question? Oh, we did. You're absolutely right. Go back. Use your graph to find the value of x when y is 0.3. So when y is 0.3, let's go to where y is 0.3. Thank you so much, whoever said that. Y is 0.3 here. So I'm going to go from y equals 0.3 until I hit my line. And then I'm going to go down and see what x that matches up to. An IGCSE is an international GCSE. It's sat in a lot of private schools, but also schools abroad use it as well. So that's going to be 2.6. Well done if you said that. Thank you for whoever noticed that I hadn't done it. 2.6. Amazing. This is a calculator paper. Right, back to our transformation. It's either going to be rotation, reflection, enlargement, translation. Okay, so rotation is when it's turned. Now, some of you thought this might have been a rotation. If I turned A to B, it wouldn't be that way up. If I'd rotated it, it would be like that way round. The high side would be on that side, wouldn't it? So that's not going to be right for this one. An enlargement is when it gets bigger. This isn't any bigger, is it? So that's not right. Translation is when it's just moved. Now, if it had just moved, it would be in the same orientation. So it might look like this, for example, but over here, like that. That would be a translation, and it isn't that. So this is a reflection. So we're going to get 1 mark for saying reflection. What's the other mark for? Good. Well done, everyone that said reflection. What's the other mark for? Yes. We need to give the mirror line, don't we? Okay, not a midpoint, nothing like that. We need to give the mirror line. So we need to give the mirror line in which this is reflected in. And remember, that mirror line is going to be the same distance from the shape on both sides. So it is going to be that. Now, you can either call this the x-axis, or you might have called it the line y equals 0. Because that's the line y equals 0, that's the line y equals 1, that's the line y equals 2, and so on. So a line going that way is normally called y equals yes. Well done, Tamsin. Translation is when it's just moved. So if it's somewhere else. So if, for example, I had it over here, like that, that would be a translation. It's just been moved somewhere else. And normally you give a vector with that one, okay? Well done. It's a reflection in the x-axis. That is the x-axis. That's the mirror line. If you turned it round, it might make more sense if you put your head on its side. Put your head sideways. It might make more sense to see it. Yeah? Cool. Question number 15. Oh, I remember this one. The ratio of the cost of 1 meter of cotton fabric to the cost of 1 meter of silk fabric is 2 to 5. Complete the table of costs. Okay, so you guys, if you watch me often, you'll know for ratio, I like to do little lines like hangman. So if we've got 2 little lines and 5 little lines, and the 2 side is for cotton, makes sense. Cotton's going to be cheaper, and the silk side is 5 little lines. So the ratio there being 2 to 5, I'm going to do it like that. Okay. I then know that cotton is £6 for 2 metres. So it'd be £3 for 1 metre, but it doesn't really matter because it's going to be in proportion. So cotton is £6. I'm then going to divide that by 2 because cotton here is £6. So that means I've got 3 on this line and 3 on this line, which means that all of the lines have 3 on them, which means that silk is £15. Therefore, when cotton is £6, silk is £15. How am I now going to get from cotton 2 metres to cotton 6 metres? Well, it's 3 times bigger, isn't it? So that's therefore going to be £18. We're timesing by 3. The cost of 2 metres, the cost of 6 metres, it's going to be 3 times bigger. Yes, well done everyone saying times by 3. Brilliant. And the same with the silk. If I times that by 3, I get 45. Now, 8 metres. You've got a choice with 8 metres. You could times the 2 metres by 4. That would work. Or you can add these two together. I also times that by 3. That's where I got 45 from. Yeah, a bit of an odd question, this one, isn't it? We don't often see this one. I love that because some of you have done so many lives with me now. You're like, oh, this is different. So either way, we're going to get £24 for that one and £60 for that one. How am I going to get 9 metres? The 15 came from up here. We knew that if cotton was £6, then each section was 3, which means all of these were 3 as well because of the ratio 2 to 5. This is foundation, 7 till 8. Higher starts at 8 o'clock. Yes, good. So we know that 1 metre would be £3 for cotton and £7.50 for silk because it's half of this. Sorry, that should be a 3. I've just drawn it really badly. I knew someone was going to think that was a 5. I thought that when I drew it, I thought that looks like a 5. There you go. Thank you, Katie, for the gifts. So then this one is going to be £27 because I'm adding on that extra 1 metre. Or you could times by 4.5. Leah, I love that idea. That's great. We've got a calculator, so why not? Love that idea. Well done. And then for the bottom one, it's going to be £67.50. Because again, I'm getting that 8 metre cost and I'm adding on 1 metre. Or you can just take this one and times it by 4.5. Like Leah said, that would work. Loads of different ways you can do it. But this is a proportion question. What's important about this question is that we're remembering that everything is in proportion. So whatever you're timesing by. Okay, question number 16. Oh, it's a lot of words, isn't it? Chloe has a van. She's going to use the van to deliver boxes. Each box is a cuboid, 40 by 30 by 35. And we can see that in the picture there. This looks awful. Don't be put off. Every time you get to a question that has lots of writing and is worth lots of marks, just change your mindset and think, okay, there's lots of marks available on this, right? There's lots of marks available. Oh, sorry, yeah, is it slightly off the screen? There we go. Chloe has a van. She's going to use the van to deliver boxes. Each box is a cuboid. The space for boxes in the van has a maximum length of 2.4, a maximum width of 1.5, and a maximum height of 1.4. The space for boxes is empty. Chloe wants to put as many boxes in the van as possible. She can put 3 boxes in the van in 1 minute. Assume that the space for boxes is in the shape of a cuboid. How many minutes does it take Chloe to put as many boxes as possible into the van? Blimey. Right, break it down. So the first thing we're going to think about, let me do a very bad drawing of Chloe's van. So Chloe's van is 2.4 metres long. So my first question is, how many 40 centimetres can we fit in her van going backwards? So my question is this: how many 40 centimetres can you fit into 2.4 metres? Now, you might prefer to think of that as 240 centimetres. And if I do 240 centimetres divided by 40, we can find out that I can fit 6 boxes. Guys, how good is this drawing? I can fit 6 boxes going back. Okay, I can fit 6 boxes that way. No, don't skip it, because honestly, this is how many marks? 5 marks in total. And that means there's so many marks available just for having a go. Definitely always have a go. Now, going sideways, her van is 150 centimetres because it's 1.5 metres. How many 30 centimetres are going to fit into 150? 1, 2, 3, 4, 5. 150 divided by 30 is 5. So we've got 6 boxes going back times 5 boxes going across. How many boxes are going to fit going up in her van? So going up, we need to think about the height, which is 1.4, which is 140 centimetres. So we're going to do 140 centimetres divided by 35, which means I've very much not drawn this to scale, but I hope you'll forgive me if I go 1, 2, 3, 4. The boxes have got a bit bigger, but you'll have to just bear with me. Yeah, good. So because this was 140 and we knew the height of her little boxes was 35, we're going to fit 1, 2, 3, 4 boxes going up in the van. So in her van, she can stack 4 on top of each other. She can fit 6 going back, and she can fit 5 going across. So if I want to know how many boxes are going to fit in the van altogether, it's 6 rows of 5, and we can do 4 on top of each other. So 6 times 5 times 4 is 120 boxes. That she can fit in her van all together. It's 6 because we did 240 divided by 40, because 240 was the total length, 40 was one little box. So she can fit 120 going in. She can put 3 boxes into the van in 1 minute. Good, well done, Anna. Anna said divide by 3. 120 divided by 3 means it would take 40 minutes. Because she can do 3 in 40 minutes. The 240 came from the fact that the length of the van was 2.4. And so if the length of the van is 2.4, then it is 240 centimetres going back. So we can fit 6 rows in, and we can fit 5 columns, and we can fit 4 on top of each other. So 6 times 5 times 4 is 120, divided by 3 is 40. Don't skip it. So 40 minutes. The space for boxes might not be in the shape of a cuboid. Explain how this could affect the time it would take Chloe to put as many boxes as possible into the van. That's not a very nice question, is it? So if it was a weird shape, it may fit less boxes. Let's say her van was like a weird oval shape, then it might be 2.4 long in the middle, but you're not going to be able to go right to the edges, yeah? So it may fit less boxes, which means it would be quicker. If she's got less boxes going in, it'd be quicker, wouldn't it? This is 2017 paper 3. Okay, question number 17. And we are factorising. What does factorise mean, please? In the comments, let's go, let's go. What does factorise mean? I'm looking for a word beginning with B. Yes, Lou. Yes, Lily. Yes, Elle. Yes, Leah. Good. Dazzling. Lewis, well done. Good. Everybody saying. We are putting it into brackets. Now, to do that, we need to think, what do these two terms have in common? Yeah. Yes, Tom. What do these two terms have in common? They are both in the 4 times table. So we're going to take a 4, put it outside. And then we need to think 4 times what is going to give 4m. So we need to put the m here. It's November. And then 4 times what to give 12? That is going to be add 3. Good. So a couple of you put 2 on the outside, which wouldn't be wrong, but it's not factorising fully. We always want to take as much outside as we can. So well done if you said that. 4 lots of m add 3. That would be our answer. 4m add 3. Factorising is the opposite of expanding. Okay, part B. Choose 2 words from the box above to make this statement correct. 5y is a blank. In the blank, 3x add 5y. Anyone know? Anyone know? Oh, thanks for the likes on YouTube. I didn't even know that was a thing to like on YouTube. There's little hearts on the screen. And people are liking on TikTok. Oh, going nuts. I love it. Woo! Paige is saying expression, then term. Term, then expression. Expression, equation. Term, expression. Formula. Okay, so an equation would have to be something like 3x add 2 equals 11. So an equation is going to have an equal sign in it. This does not have an equal sign in it, so I'm going to rule out equation. An inequality would be something like 2x add 5 is less than, or maybe less than or equal to 9. So I'm going to rule out inequality. An identity usually has 3 little lines. So an identity is something like A plus B is an identity to B add A. So identity just means that those 2 things are the same, just written differently. So I'm going to rule out identity. We don't have an identity here. A formula also is going to have an equal sign in it. It might be something like the area of a triangle is base times height divided by 2. That's something like a formula. So I'm going to rule out formula. A factor is something that fits in. So for example, 2 is a factor of 10. But I don't think 5y is a factor of this because it doesn't divide it. So factor I'm ruling out. And a multiple is like 10 is a multiple of 2. So I'm going to say no to that one as well. So well done if you said it is a term in the expression. An expression is just lots of algebraic terms without an equal sign in it. Well done. A term in the expression. Yes, well done, everybody. Thank you, Abdul. That's really kind. Okay, question number 18. Here is a sequence of patterns made with counters. Now, the first thing I always do when I see a picture of sequences is I ignore the pictures and I write the numbers. Because I'm a numbers kind of gal. So in the first pattern, I'm just going to write this as 4. 1, 2, 3, 4. In the second pattern, I'm going to write 7. In the third pattern, I'm going to write 10. And now it's a little bit easier to get the nth term, which is what they're asking me for here. They're saying, what's the rule? What's the expression? Okay, good. We're going up in threes. Okay, so I'm going to say for this one, for the nth term, I remember Dino. And that is the difference in front of an n and then zeroth. That's going to make no sense, but it might do by the end of this, hopefully. So the difference, what are we going up in? We're going up in 3. So the difference goes in front of an n, so 3n. And then if the first term is 4, the 0th term, what number would go here in the sequence? I know it's pictures, so it doesn't quite work on this one, but you have to just humour me. If I went back 3, what would I get to? Good, Paige. Well done. Both pages. It's a positive one, isn't it? So some of you are saying -1, but I wouldn't get back to -1. I'd get back to +1. And that's because this is the 3 times table, but 1 bigger. It's the 3 times table made 1 bigger. So instead of it going 3, 6, 9, it's going 4, 7, 10. So it is indeed 3n add 1. Bayo has 90 counters. Can Bayo make a pattern in this sequence using all 90 of his counters? You must show how you get your answer. We'll do another one in a minute. Let's just answer this one and then I might give you another one just to practice. So is 90 going to be in the 3 times table add 1? We're not going to do 3 times 90 add 1. I'm not saying, if they said how many counters in the 90th pattern, then I would do 3 times 90 add 1. For this one, I'm saying, can it equal 90? Can 3n add 1 ever equal 90? Can we use all 90 counters up? And the answer is no, because if we take away 1 from both sides, 3n would need to equal 89, and 89 is not in the 3 times table. It would be a decimal. It's not going to work, is it? So we know that all of the numbers in this pattern are 1 bigger than the 3 times table. And because 90 is in the 3 times table, we know that 91 is going to be in the sequence, but not 90. Right, I'll give you one more. Let's see if you can give me the nth term. So remember, it's the difference in front of n, 1 in front. So if I went, let's do 1, 5, 9, 13, 17. What's the nth term, please? Go, go, go. What's the nth term? This is foundation still currently. I'm just about to switch to higher. Just about to switch. We're just doing the nth term very quickly. Good. So the difference is 4. Put that in front of an n. And then if you go back, what number would go here? It would be -3. This is the 4 times table, but 3 smaller. So well done if you said 4n -3. Okay, for higher, we're going to do the same paper. I'm imagining that this is the first question on the higher paper. So if you are foundation and you want to stay along and watch, I just remembered how much I hate that question. If you're doing higher and you want to stay along and watch, that is great. Please, can someone remember that the last question, that one might not be on it, but it's that one. Right, let's go download it. So we're doing 2017 question, paper 3. Yeah, I told you that would be the first question. So if you're doing foundation, you can carry on watching because we're still going to be doing foundation questions for the first sort of 15, 20 minutes. Because there's the crossover section of the paper. So here we go. So if you're doing foundation, where did the overlap end? That was on foundation. That wasn't. So here. end of foundation. So if you want to watch up till question 8, that would be really helpful. That's going to be the end of the foundation paper. But you don't have to. You've already done an hour of revision if you're foundation. It's 2017 paper, November 2017, paper 3. I'll give you all a minute just to get it. For those of you that want to crack on, have a go at the question. Yeah, we're on the higher now, but we're also on the crossover. So foundation and higher, this is good for this bit. Ooh. Anyone else tired? Just me. Grace, I've been doing this for 2 evenings a week since, I think I started at the start of December, you know. I had a break over Christmas and I had 1 week off at Easter. But I'm definitely not doing it over summer. I'm undecided on whether I'll do it in September again. I don't know yet. I know you guys really appreciate it, but it is a lot of time. Please do a tutorial on how to find the paper. So if you just go to Maths Genie, you can just Google, it looks like this, scroll down to higher, and we're doing November 2017, paper 3, which is just here. And then loads of you always ask me, how do I open it on my iPad? I just click the share thing, and then I open it in PDF viewer. And then that's what it looks like that. Okay, are we ready? Shall we begin? 3 more weeks, I know. Only 3 more weeks. Well, 4. I'm going to do one the night before the exam, I think. On the Thursday, I'll do it, I think. Or is it on the Wednesday? I don't know. I haven't decided. Yeah, it's on the paper 1 is on the 19th, and it is the 19th today, so there we go. I think I put up what I'm going to do. I can't remember what I said, but it's on my TikTok. I did a video being like, these are the dates I'll be live now. Fabulous. Happy? Let's start. Okay, so first question, we are looking for the class interval that contains the median. So class interval is just a posh way of saying category. So this is a class interval, this is a class interval, this is a class interval, and so on. So they're just asking you which class interval, which category is the middle person in. Now, thinking about the fact that there are 80 people here, if we added up the frequency, we'd get 80. But we're also told in the question that there are 80 children. So this adds up to 80. Where is the middle person? Now, if you want to know the position of the middle person, we add 1 and divide by 2. So 81 divided by 2 is 40.5. So the 40th and the 41st person, they are in the middle. Now all we need to do is find where that 40th person lies. So the first 4 people are in this category. We still haven't got to the middle. We haven't got to the middle, the 40th or the 41st person yet. Then the next 11 people are in this category. So at that point, we've had 15 people so far. We've still not quite got to the middle. Then we've got another 24 people, which takes us up to 39. So at this point, we have had 39 people so far. And that means that the 40th and the 41st person are both in that category. So we can confidently say that the class interval or the category that contains the median being the middle person, is going to be 160 to 170. And we write it exactly as they do. Happy with that? So that's where the middle person is. Mean is really difficult. It's when you add them all up and divide by how many there are. Median, I think, sounds like medium, so that's the middle. And mode is the most common. Mode sounds most like most. To find the middle, you add 1 and divide by 2, which is 40.5. So that tells me that the median, the middle, is between the 40th and the 41st. If you imagine lining 80 people up, you'd have 40 on one side and 40 on the other. So technically both the 40th and the 41st are going to be in the middle. If you forget that, don't stress too much because it's likely that the 40th would have given you the right answer. It'd be fine anyway. Yeah, don't make me sing the hey diddle diddle, but yeah, that's a good way of remembering it. I'm not singing it though. Okay, frequency polygon. So if you've watched me lots, if you've been on my lives every week, you'll know for a frequency polygon, we like to remember Polly the shark. And Polly the shark, she lives in the middle of the ocean. Now, the reason we do Polly the shark is because usually these questions make a little shark fin shape. They don't always, but it helps me to get my students to remember that it's not a bar chart. It's not the S-curve one, that's cumulative frequency. So Polly the shark is how we're going to remember that a frequency polygon, Polly lives in the middle of the ocean. She doesn't live on the beach, that would be ridiculous. So Polly lives in the middle of the ocean. So remember that we're going to go in the middle of each category. I love how all of you have been on my live so much that you're all familiar with Polly the shark. Yes, I'm a teacher. I've been teaching 11 years. I'm a head of maths, GCSE examiner. So with all of my students, every year we say Polly the shark, and that helps us remember that a frequency polygon looks a little bit like this. I'm not guaranteeing, but it's always going to go up and come back down. But it is going to be straight lines joining them up, yeah? So first things first, let's do the first category. Now, the first one is 4, and that's 130 to 140. So we're going to go in the middle of the category because remember, Polly the shark, she lives in the middle of the ocean. She doesn't live on the beach. That would be silly. 140 to 150, that's 11. So we're going to pop that there. 150 to 160, that's 24. So that's there. And remember, we're going in the middle of the category for each of these. 160 to 170, that's 22. And 170 to 180, that's 19. Cool. And then all we do, I mean, that was a bit of a rubbish shark fin, but you get the point. It's not always going to make a perfect fin. There was one year where my students, my year 11s, came out of the exam and they went, Miss, Polly had 2 fins. And it went up, came down and went back up again. But I still knew they'd got the marks because I still knew they'd drawn it right. Do you know what I mean? Like they didn't draw bars. I know it's a silly way to remember it, but somehow it always works for the students. So Abdullah, I'm very well, thank you. Although I saw you said GCSE maths tutor was your favourite, so I'm a bit upset, to be honest. Polly's never wrong. Polly's never wrong. Yeah, so I do this on a Wednesday and a Sunday every week. Sundays for subscribers only. You can subscribe on TikTok. Yeah, fab. So that's Polly the shark. We happy? Yeah, we don't join up to the origin and we don't join them up at the bottom. Always plot in the middle of the category and just plot the frequency. Okay, cool. In London, 1 litre of petrol costs 108.9 pence. In New York, a US gallon of petrol costs $2.83. 1 US gallon is 3.785 litres. £1 is $1.46. In which city is petrol better value for money? London or New York? Good. I'm glad it's not me. Can't stand this question. So we need to get them in the same amount, right? At the minute in London, we've got 1 litre is 108.9p. And in New York, we've got 1 US gallon equals $2.83. So we've got a problem here that we can't compare them because we've got litres in London, gallons in New York, and the cost is different as well. So we need to get them in the same. We need to get them in the same amount. So I'm going to say that 1 gallon, I'm going to change that into litres. So I'm going to say that that is 3.785 litres. And that is $2.83. This is how it works best in my head anyway. I'm not saying this is necessarily the best way to do it. So that is 3.785 litres for $2.83. Now to go from pounds to dollars, we are going to times by 1.46. To go from dollars back to pounds, we're going to divide by 1.46. So to get this into pounds, I'm going to divide it by 1.46. So I'm going to do 2.83 divided by 1.46, which tells me that this is £1.93. It's 83. Let's keep it for a bit. But that is for 3.785 litres. And in London, we've got 1 litre. So we could divide this down or we can times this up, but we need to get the same amount, right? So whichever way you do it, I think I'm going to go 1 litre. I think I just prefer it. So 1 litre in New York, we're going to divide by 3.785. So I also need to divide that cost by 3.785. And that is 0.51211. And remember, that's in pounds. So basically, it's 51p. 51.2p. And then always, when they ask you a question, we need to answer it. Remember, you're not going to get full marks unless you've answered their question. So they said, in which city is petrol better value for money, London or New York? So it is cheaper in New York by quite a lot. But that is not the only way to do it. You could have converted this loads of different ways. The mark schemes will have all of the methods in them. But it's quite overwhelming. You could answer them. Yeah, exactly. The answers are so different. And that would make you think, oh, I've done something wrong because 51p is nowhere near that. It's conversions, currency conversions, metric imperial conversions, and so on. Okay, question number 3. We're going to need a triangle here. I can already see it. I can feel it in my bones. Density, mass, volume. A gold bar has a mass of 12.5 kilograms. Uh-oh. I'm sensing unit confliction. The density of gold is 19.3 grams per centimetres cubed. This is a calculator paper. I've got my lovely pink Class Whiz calculator. Do I tell you guys, look, I got the new one. I don't like it though. Look how asymmetrical it is. What do we think? Pink one's better, isn't it? Absolutely. Okay, so we've got the mass, we've got the density, and we're being asked to find out the volume. So when we want the volume, we're going to cover that up and do the sum that's left behind. So we're going to do mass divided by density. Covering up the volume, we get mass divided by density. Now, all of your units need to match up. We can see on the answer line that we've got volume in centimetres cubed. We can also see that we've got density in grams per centimetres cubed. But we've got the mass currently in kilograms. And that is just not going to work. We need all the units to match up. So the easiest way to match all of these up is going to be to change the kilograms into grams. So 12.5 kilograms is 12,500 grams, because to get from kilograms to grams, we times by 1,000. So now we can do our sum. Oh, guys, I've run out of water. Dying. So So now we can do our sum. Volume is mass divided by density. Wait, it's gone the wrong way. I'm going to have to go get some water. Mass divided by density. So we're going to do 12,500 divided by 19.3. We're going to pop that in our calculator, if I can. There we go. Hero. Oh, thank you. Thank you, darling. Oh, saved. It's better. Sorry, everybody. Okay, there we go. 647.668. No, I'm. Everyone's saying, what am I eating today? I'm getting a reputation for always having snacks on these lives. It's my husband. He's a feeder. He likes to keep me well fed. It's been a long day, guys. You've always got to have snacks. I actually don't have any today. I'll have a word with him. Don't worry. So 3 significant figures. So 6 is your first significant figure, 4 is your second significant figure, and 7 is your third significant figure. And the next number is a 6, which rounds up. So to 3 significant figures, it is going to be 648. Well done, Mads. Yes, brilliant. If you weren't told what to round it to, I'd probably just do 1 decimal place, or 3 significant figures is probably normally going to be okay. In that case, if I wasn't told, I probably would have done 647.7. But normally you are always told, because it just helps the examiners, because then everyone's answer is the same rather than being different things. Okay, question number 4. There are only blue pens, green pens, and red pens in a box. The ratio of blue to green is 2 to 5, and the ratio of green to red is 4 to 1. There are less than 100 pens in the box. What is the greatest possible number of red pens in the box? So we've got blue to green. Oh, hello. Sorry, everybody. We've got blue to green is 2 to 5. And then we've got green to red is 4 to 1. What is my problem here? Why don't I like this? Why don't I like this? This is a problem. Yes, good. Oyen saying they are not the same. The greens should be the same. Let's make green the same. What should we make the greens? What should we make the greens, everybody? What should we make them? 20? Yes. L, Katie, yes, lovely. Everyone's saying, let's make them 20, and then they'll be the same, won't they? Now, what have I multiplied this ratio by to make this 20? I've multiplied it by 4, so I also need to do the same on the other side and times it by 4, so that is going to be 8. On this ratio, I've times by 5, so I also need to times the other one by 5, and that is 5. So I now know that for every 8 blue, there is 20 green, and there are 5 red. There we go. Now, that is a feasible solution. That is going to add up to be less than 100. In fact, that makes 33. So if that was the answer, there would be 33 pens in the box, which is great. That's less than 100. But we want to go as big as we can without going over 100, right? We want to go as big as we can without going over 100. So how big can I go? Yeah, so Elle's saying, let's make it 99. That's going to be the maximum number of pens because we've got to stay in this ratio. So I could double it and get 66 pens, but that's not going to really get me the most, is it? I want to go as big as I can and still be under 100. So we're going to times by 3, and that's going to be 24 to 60 to 15. So the greatest possible number of red pens in the box is indeed 15 red pens. That is my answer. Well done if you got 15. That's really tricky, that one. This wasn't a particularly nice paper actually so far, was it? Except for Polyvus Shark. We love Polyvus Shark. Lots of people going, oh, yeah, that makes sense. Cool. Question number 5A. Find the value of the reciprocal of 1.6. Give your answer as a decimal. But I hear you shout through the screens. But Hannah, reciprocals are for fractions. Yeah, this is higher, but these questions are also on foundation. We're in the crossover bit, where it was the end of the foundation paper and the start of the higher paper. So I hear you saying reciprocals are for fractions. And you'd be right. So let's write it as a fraction, because that's going to be way easier. So 1.6, I think the easiest way to write 1.6 as a fraction is to say 16 over 10. I think that's the easiest way to do it. Because 1.6 is 16 divided by 10, which is 8 over 5. Now we can do the reciprocal. And the reciprocal is when you invert the fraction. So if it's as a fraction, we're just going to put the denominator on the top and the numerator on the bottom. So the reciprocal of 8 over 5 is 5 over 8. But they wanted us to give it as a decimal. Now, even if you got to that point, you still didn't get any marks for this question because it was only 1 mark and you had to write it as a decimal. Now, luckily for us, this is a calculator paper. So you can just type that in your calculator and get what it is. However, if you didn't have a calculator, we should know that we can get any decimal by doing the bus stop method. So how many 8s go into 5? Well, it fits in 1 whole time. No, it fits in no whole times. Remainder 5. 8 into 50 goes 6 times, remainder 2. 8 into 20 goes twice, remainder 4. And 8 into 40 goes 5 times. So this is 0.625. But you had a calculator for this one. So you were all good just to use your calculator and type 5 divided by 8 or 5 over 8. I've used 16 over 10 because I thought it was the quickest way to write it as a fraction. But you could have written that as 1 3/5, and that would have got you straight to 8/5. You flip it because that's what the reciprocal means. So the reciprocal of 2 is a half. The reciprocal of 3 is a third. The reciprocal of 2/5 is 5 over 2 as well. Does that help? So that's just I think reciprocal is just, when you invert the fraction. A number will times by its reciprocal and make 1 always. Okay, Jess rounds a number to 1 decimal place. The result is 9.8. Write down the error interval for X. Did you know that that's what Beyonce's writing her songs about? When she writes, what's that song? To the left, to the left. I make myself laugh anyway, even if I just annoy you guys. I don't mind. So your error interval arrows go to the left, and the bottom one is going to be equal. What is the absolute smallest that 9.8 could be if we rounded it to 1 decimal place? So rounding to 1 decimal place, whatever you've rounded to, you half that amount, okay? Half of that is 0.05. So we're going to go 0.05 below and 0.05 above. 9.75 is the smallest this number could have been and rounded to 9.8. And then we go the same amount above, but it can't actually equal 9.85, because if it actually equaled 9.85, then it would round up to 9.9. So that's why we just put this symbol in. Because for those of you saying 9.84, what about 9.8499999999? And then we go so infinitely close that we might as well just call it this. And therefore, we use this symbol, but we just don't put the equal to. So your arrow should be going to the left, and we put an equal to at that end, but just less than at that one. Yes, you always do those symbols for error interval. Yeah, exactly, Ella. It's also called bounds. The topic is called bounds. Happy with that? It's just saying what's the biggest and the smallest it could have been before we rounded it. Good. Well done, Gail. To the left, to the left. You're going to have that song in your head now. Here is a rectangle. The length of the rectangle is 7 centimetres longer than the width of the rectangle. 4 of these rectangles are used to make this 8-sided shape. The perimeter is 70. Work out the area. Is there a nicer question in the world? I love this one. We're on both. This is the end of foundation, but the start of higher, so we're on both. Yes, the arrows always go to the left. That's what Beyonce was writing about, obviously. So I'm going to say the width of this rectangle is X. And if the length is 7 centimetres longer, then the length is going to be X add 7. Now, 4 of these rectangles are put together. So I'm going to go ahead and I'm going to label X add 7 here. This bit would be X. This bit would be X add 7. This bit would be X. This bit would be X add 7. This bit would be X. This bit would be X add 7. And this bit would be X, because we're going all the way around the outside. But I've got a little bit of a problem in that I don't have that bit at the minute and I don't have that bit at the minute. So perimeter is all the way around the outside. So we've got most of the sides around the outside, but I don't have this bit. Now, let's just look in just real detail here. If you know that this bit is X add 7, and you know that this bit on the inside, which we're not going to include for the perimeter, but I know that that bit is X, then this bit here, it's not going to be half, because I know that this is X. So if this is X add 7 all the way across, and this bit is just X, then this bit here must just be 7. Yeah, well done, Amber. Well done, Sophia. Well done, Evie. It's going to be 7, because together it needs to make X add 7. So if it's X add 7 all the way across, and we know that the edge of the rectangle is X, so we know that the top of this one here, we know that that's X wide, we can take that X off, and we're left with just 7. So I'm going to get rid of this bit now, and I'm going to zoom back out. And I also know by exactly the same working out that this bit over here is also 7. Okay, so now we've got the perimeter all the way around the shape. So I know that all of this added together, and let's start from here. I like to do a starting point when I do perimeter, or else I lose track of where I started. All the way around the outside equals 70. So X add 7, add X add 7, add X add 7, add X add 7, add X add X add X add 7 equals 70. Now, I'm not going to write all of that out because it would be madness. So what I'm going to do instead is I'm going to colour in all of the X's in yellow. So 1, 2, 3, 4, 5, 6, 7, 8. So I've got 8 X's. And then in blue, shall we do it? I've got 7, 7, 7, 7. Oh, it's feeling like Strictly Come Dancing. 7, 7 up there. So I've got 1, 2, 3, 4, 5, 6 lots of 7, which is add 42. So 8 X's, add 42, needs to equal 70. I definitely do not have a beautiful voice. I thank you for the kind words, but I'm also not an idiot. I sound like a man. Oh no, I sound like the lady on Maths Watch, apparently. The students in my year 11 class probably wouldn't say that, but thank you for your kind words anyway. So 8x add 42 equals 70. So we're going to solve this. And when I solve, I like to do a dotted line where the equals is. And what we do to one side, we're going to do to the other. So I'm going to take 42 away from both sides. I was going to say something awful about how deep and manly my voice is, but maybe the lady from Maths Watch is watching. I don't want to insult her. So take away 42 is going to be 28. And then we're going to divide by 8, which is indeed 3.5. Well done if you said that. Now, we're not done. We're not done. And it is a 5 marker, so I'm not particularly surprised that we're not done. But they asked us what the area of the shape was. Now, each rectangle was 3.5 wide because we knew that that was x, and the length was 7 longer. So the length is 10.5 because to get from x to x add 7, we're just adding 7. Each of these rectangles then is 3.5 times 10.5. Yes, this was a calculator paper, which is 36.75. And how many of them were in our shape? 1, 2, 3, 4. So the total area of this big shape is just 4 of those. Oh, typed the wrong thing in. Which is 147 centimetres squared. Ta-da! Yes, well done. Lots of you with the right answer in the comments. Well done. This topic is called forming and solving equations. The 70 came from the question. So they told us in the question that the perimeter of the 8-sided shape is 70. So we could make it equal 70 because they told us that's what it made. The 10.5 came from the fact that this was x and this one was x add 7. So we knew that if this one was 3.5, to get the width or the length, whichever way you called it, you'd have to add 7 and that would be 10.5. They told us in the question that the length of the rectangle is 7 centimetres longer than the width. So we called the width x, and therefore we knew that that one was x add 7. The 42 came from all the blue 7s added together. Because we were doing the perimeter, we were adding up the distance around the outside. So we had to add all those 7s up and all the x's up, and that's how you got it. This is the crossover. There is 2 more questions, I think, on the crossover to the end of foundation. Okay, question number 7. Work out that. Give your answer as an ordinary number. Now, we've got a calculator. So we're absolutely just going to type this in. Let me see if I can angle this to get it live, to get the calculator on YouTube and on TikTok. That works. Now I just need to not move it. Everyone can see it now. So we're doing bracket 13.8 times 10 to the power of 7 times 5.4 times 10 to the power of minus 12. Cool. Oh, I moved it. I didn't mean to move it. Can we all see it? There we go. 7.452 times 10 to the power of minus 4, and that's it. Lovely. We'll take that. That was a nice 2 marks, wasn't it? Lovely. Next question. When a drawing pin is dropped, so many words. When a drawing pin is dropped, it can land point down or point up. Lucy, Mel and Tom each dropped the drawing pin a number of times. The table shows the number of times the drawing pin landed point down and the number of times the drawing pin landed point up for each person. So Lucy did it, those were her results. Mel did it, those were her results. And Tom did it, those were his results, right? Rachel's going to drop the drawing pin once. Whose results will give the best estimate for the probability that the drawing pin will land point up. So Mel is the correct answer here because she did it the most times. So Mel did it more than anybody else did it. Hold up, Hannah, stop. Oh my goodness. I'm losing marks left, right, and centre. Actually, I lied. That's the first mark I lost. Right, as an ordinary number, I should really learn to read the question. Thank you, everybody. So 10 to the power minus 4 is going to be divide by 10, divide by 10, divide by 10, divide by 10. So it's going to be 0.0007452. There we go. All is right with the world. I know. Read the full question. I always write this on my students' work. Read the full question, guys. Shameful. That is embarrassing, isn't it? Sucks to be me. No, it's all good. We're all human. Losing silly marks, exactly. So when you do 10 to the power of minus 4, that means divide by 10, divide by 10, divide by 10, divide by 10. So I'm taking 7.452 and I'm moving it. I do need to write it on my own work. I was testing you. I wasn't. I'm just half asleep. We've got to move all the digits 4 times over, and that puts the 7 in that column. Okay, Mel did it the most times. So the more times you do something, the more accurate your results. If I flipped a coin and it landed on heads, I can't then say, oh, it lands on heads 100% of the times. It just did it because I did it once, right? The more times you do something, if you do hundreds of times, thousands of times, then your results are going to be more accurate. Equally, if you do a survey and you ask 5 people, the results are going to be more accurate if you go and ask 5,000 people. So the more times you do it, the more accurate your results are. So Mel, she did the throwing of the drawing pin the most times. So I would say that her results are the most accurate. So we've got drawing pin. Lucy's chucked it 45 times in total. Mel's chucked it 80 times. And Tom's chucked it 25 times. So I trust Mel's results the most. No, I'm not the Maths Watch lady. I need to meet her. I think we'd be best friends. Who is she? Can we find her? Should we track her down? Right, Stuart is going to drop the drawing pin twice. Use all the results in the table to work out an estimate for the probability that the drawing pin will land point up the first time and point down the second time. So we need to use all the results in the table. So even better than just using Mel's results would be putting everybody's results together. So we're saying that if we added up everyone's results, we'd get the most accurate results ever. So I'm going to add together all the point downs. So 31, add 53, add 16 means that all together it landed point down 100 times. And then I'm going to do point up, which is 14, add 27, add 9, which is 50. So it landed point down 100 times and it landed point up 50 times, and they threw it in total 150 times. Now we need to work out the probability of it landing point up the first time and point down the second time. What is the probability of it landing point up? What is the probability of it landing point up? Well, it landed point up 50 times out of 150. Now think about your tree diagrams. If we want the probability of something happening and then the next thing happening, we times along the branches. So the probability of it landing heads up, it landed point up 50 times out of 150, and it landed point down 100 times out of 150. Now, you don't need to cancel it down. You could type it in your calculator like that, or you could cancel it down and say that's 1/3 times 2/3. However you do it, you're going to get 2 over 9 because your calculator would cancel it down for you. Where does it say 50 to 150? It doesn't. So I added their results together. It said using all of the results in the table, because Mel did it 80 times, which is pretty accurate. We could use Mel's results. She did it the most times, so hers was the sort of most reliable. But actually, using all of their results together was even more accurate. So I added all of their results together, and putting all of them together, it landed point down 100 times and landed point up 50 times. Okay, that was the end of foundation. So moving on to higher now, which means we're on to the grade 6 questions. Jack bought a new boat for £12,500. Hi, Caden. Oh, I actually saw you say hi today. Thank you, Paige. Well done. Okay, at the end of how many years was the value of Jack's boat first less than 50% of the value of the boat when it was new? So we know that he bought the boat for 12,500 and we're looking for when it goes down under 6,250. Now we know it's dropping by 15% each year because 0.85 as a multiplier is getting us 85% each year, which means that Jack's boat is depreciating by 15% each year. It's going down in value by 15% every single year. Therefore, you can just trial and error this. Now, you could use logarithms, but we haven't learnt those at GCSE, so we're not going to bother with that. We're just going to do it. Now, I'm going to try typing in my calculator 12,500 times 0.85 to the power of, let's go 3 years. Let's see. 12,500 times 0.85 to the power of 3. And that is 7,676.56. So it's not quite enough. So now that I've already typed that in my calculator, I'm now going to go back. I'm going to go left. And I'm going to change that power to be a bigger number. So we're now going to say, okay, instead of 3 years, let's try 5 years. Oh, 5 went under. Hang on, let's check 6 then. Oh, 4. Sorry, I went the wrong way. So 4 was 6,000. You guys can't see, can you? 6,525. So the power is the number of years. And then 12,500 times 0.85 to the power of 5. That went under, didn't it? That was 5,546 and 32. So after how many years was the value of Jack's boat first less than 50%? 5 is our answer. Because the power of 5 was the first that made it go under. So that's compound interest. If you want to know the topic, compound interest or depreciation, but it's normally going to be under compound interest. A big fat 5. Love that. Okay. A savings account pays interest at a rate of R% per year. Jack invests 5,500 in the account for 1 year. At the end of the year, Jack pays tax on the interest at a rate of 40%. After paying tax, he gets £79.20. Work out the value of R. So he had 5,500 in the account. And then after a year, he's got a new amount of money. But the extra money that's been added on this to get from here to here, he needs to pay tax on. And he pays tax at 40% of this amount. If he pays tax at 40%, then he gets 60%. So we're going to say that £79.20 equals 60% of this amount. Now, if that is 60%, I'm going to divide it by 6 and times it by 10. So £79.20 is 60%, which means to get 10%, we can divide it by 6. You can just divide by 0.6 if you want to. That's £13.20. And then so 100% is £132. So he paid tax on that amount, but that's the amount that he got. If he's paid 40% tax, then he's got the rest, and the rest would be 60%. So it's £132 that he's added. So we now want to know what interest rate is that. So I'm just going to do 132 out of 5,500. And that is 0.024. And then we want that as a percentage. So I'm going to times by 100, and that is 2.4% interest. The 132 came from the fact, right? We knew that he paid tax of 40%. So we knew that the amount he got had already had 40% taken off of it. So £79.20 is actually equal to 60%. If I want to know what the 100% was, I can divide by 6 and get 10%, and then times that by 10. So if 10% was 13.2, then 100% was 132. So 132 is how much money he got after the interest had been added. And then we needed to know, okay, what percentage is that? Because we wanted to know the interest rate. So 132 out of 5,500 times by 100, because we want it as a percentage, and that is 2.4%. It's currently streaming live on YouTube, so I think YouTube does automatically save it to YouTube. But I talk so much nonsense over the top of these. I don't know that it would be helpful to anyone. This is higher now. Lives, well, I don't know. It did the other day when I did it, but I don't know. We'll see. It's now a 2-hour video on YouTube. That's mental. What topic is that? Interest. Interest. Compound interest or percentages. Interest and percentages. Better when I talk. I don't know about that, guys. I think you're being kind. Question number 10. There are only blue counters, yellow counters, green counters, and red counters in a bag. A counter is taken at random from the bag. The table shows the probabilities of getting a blue counter or a yellow counter or a green counter. So we know the probability always adds up to 1. So far I've got 0.2, add 0.35, add 0.4, and that is 0.95. Therefore, the probability of red is going to be 0.05. Because probability always has to add up to 1. Yes, Grace, well done. There we go, that's that one, 0.05. What is the least possible number of counters in the bag? You must give a reason for your answer. Yes, Neve. She's already got it. She knows. So the least possible number of counters, if I said that there was one blue counter, then I would know that 20% is equal to one counter. Well, then 5%, 0.05, would be a quarter of a counter. So that doesn't make any sense, right? It can't be that. So the smallest probability is this one. So the best I can do is say that that is one counter. So if I say that, I don't know why I thought if I did it quick, it wouldn't rub it out. So the best thing I can do is say that 0.05 is one counter. And then if that's one counter, then 5% equals one counter. So then 20%, which is blue, would be 4 counters. 0.35 would be 7 counters. 0.4 would be 8 counters. And red is the 1. So that adds up to 20. Or you can do 0.05 times by, so what would I need to times that by to get 1, to get a whole? And we'd have to times by 20. So the least possible number of counters in the bag is 20 to make them all whole numbers. That's the smallest we can go. We can't go less than that, or they'll end up being decimals, and we can't have decimal number of counters in the bag. Okay, question number 11, and always with the potatoes. Right, I'm going to have to do a little scroll on this one. The cumulative frequency graph shows information about the weights of 60 potatoes. What is the median? What is the median? So cumulative frequency graphs show the position. So all of these potatoes are in order from the potato that weighs the least to the potato that weighs the most. The median is going to be the middle potato. Now we saw in the very first question with Polly the shark that the median is going to be between the 30th and the 31st if there are 60. But on a graph, we just don't care. So we're just going to read across at 30. The 30th potato, be really super accurate with these, okay, is going to be 57. 57 grams is the median. That is the middle of the data, and that is 57 grams. Now, quite commonly, you're asked for the interquartile range. We haven't been asked for it here, but just to show you very quickly how you would work out the interquartile range, you would go halfway between the median and the top of the data. So that would be at 45. And then you would go halfway between the median and the bottom of the data. And that would be there. So if you were asked for the interquartile range, you would do the upper quartile, which is 63, take away the lower quartile, which is 52, and that is 11. If you were asked for the interquartile range, but we haven't been asked for it here, but it's a really common question, okay? Jamil says 80 take away 40 is 40, so the range of the weights is 40. Is Jamil correct? So he said, well, the top value is at 80 and the bottom value is at 40. Is he correct? He's not, is he? Because there's going to be some data, or we don't know, I guess. The data will have been grouped. So the actual highest might not be at 80 and the actual lowest might be just between these values. So with a cumulative frequency, we always plot at the top of the category. So we don't actually have the original data. So data has been grouped. Well, I've gone for necessarily and now I can't remember how to spell it. We'll go like that. Not necessarily. The data has been grouped. 40 may not be the lowest. There we go. Show that less than 25% of the potatoes have a weight greater than 65. Okay, so we're going to go to 65 on our graph. Let's do it in a different color. Let's use red. 65 is here. And if we go across, we can see that there are 11 potatoes that are above because it's got to 49. So 49 up to 60, there are 11 potatoes there. So 11 weigh more, and 25% of, how many were there? 60 is 15. 11 is less than 15. Sweet potato. Okay, next one. Oh, we love a tree diagram. So we're timesing along the branches for a tree diagram. So the first spin, the chance it will land on red is 0.25. The chance it will land on white is the rest, 0.75. And then we've got spinner B. Alan spins spinner A once and spinner B once. He does this a number of times. The number of times both spinners land on red is 24. Work out an estimate for the number of times both spinners land on white. So we want the probability of red and red again, which we know we get from timesing along the branches. So I'm going to do 0.25 times 0.6, and that is 0.15, which is 15%. So I can now say that 15% of the throws is 24 times. And I want to know how many throws were there altogether. So I'm going to try and get to 100%. So to do that easiest, I'm going to divide by 3 and then times by 20. So 24 divided by 3 is 8. And then times that by 20 is going to be 160. You could do that in lots of different ways, but that's the easiest way in my head. So they did 160 spins. Now we would like to know how many times both spinners land on white, which is going to be this one and this one. So 0.75 times 0.4 is 0.3. So actually, we didn't even need to do that. It's just double, isn't it? So now we're going to find 30%, which is 48 times. Happy with that? Okay, now we are completing the square. So to complete the square, we need to half this number. So I'm going to say it's x add 3 all squared Now, x add 3 squared, the reason we're doing halving it is because x add 3 times x add 3 is x squared, add 3x, add another 3x, add 9. So it gets us the 6x that we want. So we got the 6x, but then we need to take away 9 because I don't want that annoying extra 9. And then we also need to bring down the minus 7. And then it will be equal. So I've got x add 3 all squared minus 16. That's completing the square. If I then asked you what the turning point was, it would be minus 3 minus 16. It's always whatever makes the bracket equal 0 and then the other value on the end. The 9 came from the fact that when I did x add 3 squared, x add 3 times x add 3, it got me x squared, which is great because I wanted that. It also got me 6x, which is great because I wanted that. But it also got me plus 9. And I didn't want the plus 9. So x add 3 squared got me x squared add 6x add 9. But then I took away 9 to get rid of it and then brought down the minus 7. So that's that. X add 3 squared minus 16. If they asked for the roots, you can go on from there and solve it, but unlikely that they're going to ask you to solve it from there. You can probably just use the quadratic formula easier and get that. So the turning point is whatever makes the bracket equal 0. So in this case, that would be minus 3. And then whatever number is here, you stay with the same power, minus 16. I'll do one more because I feel like I've upset people doing the... And I know I shouldn't, but... I want to make you all happy, so. I know I'm multitasking massively, reading comments on YouTube and comments on TikTok and not doing a paper at the same time. And it says plus B. That's a really good question. So I know it says plus B. That doesn't mean it needs to be a positive because B is minus 16 in this case. Cone A and cone B are mathematically similar. The ratio of the volume to A to the volume to B is 27 to 8. So when we enlarge shapes, we have the linear scale factor, we have the area scale factor, and we have the volume scale factor. So if you took, for example, a little cuboid and you made that cuboid bigger, let's say this is 1 wide. No, let's say this is 2 and this is 1 and this is 1. If I made it twice as big, then it would be 4 and it would be 2 and it would be 2. Now the front face here has an area of 2 and the front face here has an area of 8. So you'll notice that the area, if the linear scale factor is 2, then the area is actually 2 squared times bigger, which is 4. And the volume of this one would be 2. The volume of this one would be 16. So the volume scale factor is actually 2 cubed. It's actually 8 times bigger. No, you don't need a ruler here. So always, to go from the linear scale factor to the area scale factor, we square. And to go from the linear scale factor to the volume scale factor, you cube. So none of that is really relevant for this question, the numbers. But we still need a linear scale factor, area scale factor, volume scale factor. So when you're making a shape bigger, the scale factor changes whether you're talking about the linear, the area, or the volume. I know you guys would have rather I spend more time on the harder question, but the truth is that there's just not as many people that need that. So I always like to make it as helpful as I can to the most people possible. And I've got lots and lots of higher content on my YouTube. But truth is, if I start doing grade 9 stuff, it's just going to terrify a lot of people. And I don't want to do that just before the exams. Okay, cool. So linear scale factor, area scale factor, volume scale factor. So the volume is 27 to 8. Now you'll notice that they're both cube numbers. And the reason they're both cube numbers is because now if I want the linear scale factor, I can cube root. So the linear scale factor is going to be in the ratio 3 to 2 because I've cube rooted. And then the area scale factor would be 9 to 4 because we've squared. So you can squared and you can cubed. Yeah, there's playlist for aiming for a grade 7 to 9 on my TikTok. And there's a playlist for aiming for a grade 5 on my YouTube. And then on my TikTok. And then on YouTube, I've got a higher and a foundation playlist. But aiming for a different grade would probably be quite good. Maybe I'll do a video of aiming for a grade 9. Okay, the surface area of cone A is 297. So if I want to go to the surface area of B, I need to use the area scale factor. So I would divide by 9 and times by 4. So 297, and we're going to divide by 9 and times by 4. 297 divided by 9 times by 4 is 132. And there we go. That's it. The topic is similar shapes. And it's 3D. So it's involving area and volume scale factor. Right, I'm going to call it there and go and have my dinner. This topic is iteration. Do the rest of the paper. And if you get really, really stuck and you want my help, drop me a message and I'll do that question on TikTok. Or YouTube, I'm not sure. Okay, fab. I'm going to end it there. Thank you so much for joining me tonight. I've loved seeing all of you as always. A reminder that the predicted papers are on YouTube. So if you want to have a go at the predicted papers that First Class Maths made, I've filmed solutions to those there. So you've got an AQA one, you've got an EdXL one, and that is the predicted paper. The paper is linked in the bio. And it would mean a lot to me if you did those and go and watch it on YouTube, because YouTube actually does pay me a little bit of money when you watch my videos. So I'd be very grateful. Thank you so much. Everything's linked in the link tree in my TikTok and linked to my YouTube as well. Riley, you're very welcome. I've just seen, if you're aiming for a grade 9, go and do the spicy questions that First Class Maths wrote. They would be an absolutely incredible thing to prepare you for getting a grade 9. So First Class Maths, if you Google First Class Maths spicy questions, they will be really, really good for that. Thank you so much, guys. Have a lovely evening. I'm going to go have my dinner. It's lovely to see you all as usual. Bye.